determine the dimensional equation of a particular physical quantity, then you will not be able to apply the dimensional analysis, or you will not be able to learn the dimensional analysis. Okay, so it is very important. So let's see some questions. Okay, so there is a first question. So here we need to determine the dimensional equation for G, initial gravitational constant, then surface tension, then thermal conductivity, and the viscosity. Okay, so we have formulas. These formulas are given in a question. So first formula is for gravitational force. So gravitational force is F is equal to G m1 m2 upon r square. Okay, so G is a gravitational constant, F is a force, m1 and m2 are the masses, and r is a distance between these two masses. Find a dimensional formula for G. You first arrange this. So G is equal to F into r square divided by m1 m2. Now write both sides. SI unit of G is equal to SI unit of this quantity. Now SI unit of force is Newton and SI unit of distance is meter, and for mass, kilogram into kilogram, you will get kilogram square. Okay, so SI unit of G is Newton into meter square divided by kilogram square. This is my suggestion that you learn or you remember the dimensional formula for force. Okay, because the force will come in number of formulas of physical quantity. So force or dimensional equation will be m1 l1 t minus 2. Okay, so you put directly here. So Newton is a SI unit of dimensional formula for force, m1 l1 t minus 2. Okay, now meter is a SI, so put length के लिए l रखें यहाँ पर l raised to power 2, and for mass, for kilogram you put mass. Okay, because kilogram is a SI unit of mass, so this is m raised to power 2. Solve करेंगे इसको, solve these values, you will get m raised to power minus 1, L raised to power 3 and T raised to power minus 2. So this is a dimensional formula for G. With a physical quantity you will get dimensional equation. So this is a dimensional equation for G. Okay, do remember the procedure. Okay, so and follow this procedure, you can be determine the dimensional formula of any physical quantity. Now the second physical quantity is surface tension, and unit of surface tension is Newton upon meter. Okay, what is surface tension? It is a force per unit length. Okay, so SI unit of S is equal to SI unit of F by L. F, for F use Newton and for L use meter, so Newton upon meter. Now to determine a dimensional formula for force, m1 l1 t minus 2, and this l1 for this meter is a SI unit of length L, so L raised to power 1. You solve it. By solving you will get m1 l0 then t minus 2. Okay, this is a dimensional formula for surface tension. Now you equate the quantity, physical quantity, with this, then you will get a dimensional equation. Okay, next is thermal conductivity. So formula is given in a question, so you arrange this equation in this form. So K is equal to QD divided by A delta theta then small d. Here Q is a heat, D is a distance, A is a area, delta theta is a change in temperature, and a small t. Again arrange this. SI unit of K is equal to SI unit of this quantity. So SI unit of heat is joule, distance की SI unit मीटर, एरिया की हो जाएगी मीटर स्क्वायर, चेंज इन टेम्परेचर की केल्विन, और टाइम की सेकेंड. ओके, so by this you can unit of SI unit of thermal conductivity. Now joule we can write Newton into meter. Joule को आप क्या लिख सकते हो? Newton into meter. Now cancel out meter to meter, then you will get Newton upon Kelvin into second. Okay, now again we know that the dimensional formula for Newton is m1 l1 t minus 2. For Kelvin you will get, when you bring it above, you will get K raised to power minus 1. Then for second is SI unit of time, so bring it above, you will get T raised to power minus 1. So when you solve it, you will get dimensional formula m raised to power 1, L raised to 1, T raised to power minus 3 and k raised to power minus 1. Okay, so this is a dimension. When you equate it with the physical quantity k, it is a dimensional equation. Okay, now let's move. So next is coefficient of viscosity. Now raise this equation also. So we'll get eta equal to F force divided by A area, then delta V is change in velocity and delta X is change in distance. Okay, so SI unit of eta is equal to SI unit of this quantity. So SI unit of force is Newton, SI unit of area is meter square, SI unit of this change in velocity is meter upon second. Okay, now SI unit of this distance is meter. So cancel out meter to meter, you will get Newton into second upon meter square. So this is a SI unit of coefficient of viscosity, Newton into second upon meter square. Okay, now again for Newton, write a dimensional formula for force m1 l1 t minus 2. For second is a SI unit of time, so write t raised to power 1. And for meter, meter is a SI l raised to power 2. When you bring it above, you will get l raised to power minus 2. So solve the powers, you will get m1 l minus 1 t minus 1. Okay, so this is a dimensional formula. When you equate it with the physical quantity, you will get dimensional equation. So this is a dimensional equation of coefficient of viscosity.